All right. Hello, YouTube. It is currently 4 a.m. Nope, it's 5 a.m. and I'm recording this video. Very sleepy, but you know what? Gonna get it done. All right. So today we're gonna learn how to find volume of very different pyramids. First one. Well, pyramids. Oh, we don't want that. We don't want that line. All right. The first 3D shape we're going to learn how to find the volume of is the pyramid. This one's actually really simple. All it is 1/3. The volume is equal to 1/3 base times the height, where base is just this part right here. And the height is from the middle of the base to the vertex. Middle of the base to the vertex. That is the height. All right, let's do an example problem. For number 1, we know that the volume of a pyramid is 1/3 base times the height. First, we are given the height is 16. So h is equal to 16. Now we need to find the base. The area of the base is equal to, in this case, it is a rectangle, so just length times width, which is equal to 10 times 11, which will give us 110. Therefore, the volume is equal to 1/3 times 110 times 16. You guys can do the math. I don't want to do that one. All right. Next, we have a cone. The cone is actually the same exact equation as a pyramid, which is volume is equal to 1/3 base times height. You might be asking, but Mr. Y, I don't see base here. Well, the base of a cone is a circle. And the area of a base for a circle is just pi r squared. So replace base with pi r squared and you will get this equation. Pretty simple. Let's do an example. We are given that volume is equal to, for a cone, is 1/3 pi r squared times the height. First, we're given that the height is 17. Perfect. Now we just need to find the radius. Oh, it's given to us, which is 9. Just plug those values into the equation and we are done. Volume is equal to, excuse me, 1/3 pi times 9 squared times 17. Put in the calculator, you are done. Now, here is a hint for number 9. For number 9, you are not given the height. However, you can make a right triangle within the cone, where the right triangle looks like the hypotenuse is 22.5, half the length of the base is 13.5. If you're given two sides of a right triangle, where this is C and this is A, they can use something called the Pythagorean theorem. A squared plus B squared is equal to C squared to find B. Pretty simple. It seems that you guys also had trouble with this concept yesterday. Might be the same for here. Or if you guys notice, if you want to find the area of the base, this one has a triangle where the height is 7.5 and the base is 12. So all I have to do is base times height divided by 2 for this one. But for the next question, number 5, you're not given the height of a triangle of the base. So we have a triangle down here that looks like so, where this is 14. This is the right angle, if you notice right here, and this is 22.1. The hint is A, B, C. A squared plus B squared is equal to C squared. Then you can solve for A. Lastly, for number 6, now we have an equilateral triangle as the base. You'll be like, Mr. Y, we don't have the height of it. Well, you can find it very simply. You can make a height of this, or you can make a right angle there. Therefore, now we have a right triangle where the hypotenuse is 10. One of the legs is 5. How do you solve for this? Try it. Lastly, let's talk about the application. For the application, you should break down the volumes into separate shapes. For instance, number 12. The cylinder to the left contains 2 congruent hollow cones. So the hollow cones are here and here. If the cylinder's height is 20 inches and the diameter is 14, so the here to here is 14, find the volume of the solid. I will give you a hint. Number 1, the volume of the solid is the entire volume, which would be a cylinder. So you would have to do volume is equal to base times height. And you subtract the volume of the cones. But there's 2 of them. So it's volume of the cylinder minus 2 times the volume of a cylinder. Alright, that's it for today. Good luck, guys. All you have to do is finish this. Hit the like and subscribe button, and see you guys tomorrow.